Hello there, welcome to the Learning of Engineering tutorials. In this video lecture, we are trying to learn what is the strain energy, right? What is the strain energy stored in a body when a load is going to be applied gradually. There are the three types of conditions we are going to be using. First one is gradually applied load, second one is suddenly applied load, and third one is impact load. And due to these reasons, then the member is going to be storing certain kind of energy. Once you remove that load, and automatically that shape and size, it will regain its positions. So then we can say, then why the strain energy is going to be coming? Because as we know, every member consists of elasticity. We know it can regain its original position after removing the load. Because of this elasticity, and that material is going to be storing some energy when it is going to be subject to the stretching or elongation or maybe the contraction time. Right? So these are the general phenomena when the external force is going to be acting on that member. Now here we can see, I took the one example here for the gradually applied load. So there we can see I have taken one cross-sectional member that is going to be circular cross-section, and the load is going to be acting on both sides which are pulling opposite to each other. So then I have taken the length of this member, it is going to be have a cross-section, the diameter, right? And these all comes to the geometrical properties. So then what will happen? When I am going to be applying the force P gradually, that means suppose the 1 newtons per second if I am going to be applying, that I am going to be continuously applying that load over there on this member. Or we can, if I am going to be applying 1 kg per second load gradually, that I will continue that for 1 second 1 kg of the load I can apply on that part. Now in this case that load is going to be acting. So then the member is going to be start to elongating, that's because of the tensile load. So then in this case, how the graph is going to be coming? There we can see the load I have taken on the vertical axis and the elongation of the member I took on the x-axis. So now in this case, up to elastic limit, the load curve and that means the elongation is going to be proportional to each other. So that means the curve is going to be forming like this. And after, if it is going to be a ductile materials, so then what happened? It's going to be moving like this. So can you see, this is going to be, the curve is related to the ductile materials. So now I want to find out the strain energy. The strain energy we are calculating within the elastic limit. It means that I am assuming this is going to be your elastic limit. Within that limit, we need to find out. So then what I am going to do? I am going to be taking the curve between. So this is going to be your the strain energy stored inside the body. Then how could you measure the magnitude of the strain energy? As we know, the strain energy is equal to the work done by the member or work done by the system. We are going to be the same here. So here, what is the work done here? How much work done is going to be? That's going to be the strain energy, indicated letter is the U, that is equal to work done by the system. So then what is the work done here? Because of it is going to be start elongating. So then under this curve we are going to be calling is the work done. So that's going to be the area of the triangle. Area of the triangle. So can you see area of the triangle? How could you find out here? As we know, that's going to be half into base into height we are going to be taking. So in this case, half into base into height, that's going to be P into del L I am going to be taking. This is. So in this case, we are going to be finding the magnitude of the strain energy by using the gradually applied load magnitude and the elongation. So can you define the same in terms of the stress as well as the Young's modulus? There we can see different parameters I was mentioned. So then how could you write the load here? If I am going to be, we know that when the external load is coming, the stresses are going to coming. That's going to be sigma is equal to P by A. So from this one, I am going to be writing P is equal to sigma into A, right? And then del is equal to, what is the formula we do have? So that's going to be the strain is equal to del L by L we are going to be taking. It means change in length to the original length. So then del L is equal to, what is the formula? Epsilon into L I can take it. And similarly, this epsilon is nothing but the strain of this object. Then we know the Young's modulus is equal to stress by strain I am going to be taking. So further I am going to be simplifying. The strain is equal to here sigma by E, I can take it. So can you see? And once the gradually applied load I am changing into the stress, and similarly the strain, that is the del L, I converted into the strain and then converted into the stress as well as the Young's modulus. Now I am going to be substituting these three values in this equation so that I can find out the strain energy in terms of the stresses. So here I am substituting what's the P value? That's going to be half into, that's going to be sigma into A, right? And del L is equal to epsilon into L. Then again I am going to be substituting U is equal to half into sigma into AL. I am going to be writing. This is going to be your strain. So the strain is equal to, that's going to be sigma by E, I can take it. And further simplification of this equation is equal to half into sigma square by E, area into length, I can write the volume, right? So this is going to be your the strain energy equation. U is equal to sigma square by 2E into volume we are going to be considering. So either you can find out the magnitude of the strain energy by using this equation, or you can find out the strain energy by using this equation. So I hope you are able to understand the mathematical model which is helped to find out the magnitude of the strain energy, right? So in this case the strain energy we have calculated by using the curve. That's why we have taken the half into base into height we have taken. But when we are going to be taking the impact load or suddenly loads, so then what will happen? We are going to be taking the force into the displacement. So from there we are going to calculating the stresses. So still if you feel any confusions regarding this presentation and any confusion, please put in the comment section so that I can reach you out. Thank you.